which of course is now relabeled climate change because scientists realize that the weather and climate does change all the time, and that covers all cases. This is a topic that I've started looking at about 10 years ago when I was starting to retire. I said, what's this controversy about global warming? What's it all about? Why can't it just be decided that it's a problem or not? But it's a very complex issue. The science is very complex to start with, and unfortunately there's a lot of politics involved as well, as you see when we get into this. Now I've got a lot of slides that I'm going to go through here, but don't worry, all of my work is on my website that's listed up here, and you can get the talk from there. After this, I'll give the slides to Chris so he can put them up on his website, and you can look at them in more detail because there's no way we can cover all this with the time that we have. So what I'm going to do is go through these topics here. First of all, what's the biblical mandate that we have as Christians in taking care of the environment that God has given us? And then I'm going to look at some of the global warming or climate change claims that scientists are making and see if they're true or not. We'll look at some climate change facts and then try to understand a little bit what greenhouse gases, the greenhouse effect is all about. And then two major organizations. The one you see in the paper, of course, is always the UN IPCC, which is the Intergovernmental Panel on Climate Change. So there are government scientists involved in that research, and they have grants that gives them the money to study this issue. But there's a totally different organization called the Non-Governmental, no government involved at all, International Panel on Climate Change. And what they do is look at the science of climate change. And how real is it? What are the projections? Are they real? And what should we be doing with it, if anything? So once we get through this introduction, I'm going to consider 16 key issues, 16 key questions that people ask about climate change. And then we'll draw a summary. First of all, what's our biblical mandate? Well, I think most of you would be familiar with these verses here from the Bible going all the way back to Genesis 1:28. Be fruitful and multiply, fill the earth and subdue it, have dominion over the fish of the sea, over the birds of the heavens, and over every living thing that moves on the earth. And then further in Genesis 8:22, while the earth remains, seed time, harvest, cold and heat, summer, winter, day and night shall not cease. And what God is saying is that he says we will always have seasons. They're not going to go away. And then as scientists, we are always to be skeptical, but also as a biblical scholar, we need to be skeptical. We should always question things that we are being told and saying, is it really true? Is it good? And we should hold fast to what is good and true. So with that in mind, let me go at a high level. Here are some of the things that were predicted by the UN IPCC. And almost every country is represented in this, and small countries to large countries. Here are some of the predictions they said. The change in the weather, the warming that we see is real and caused by humans, largely. That's what they're saying. In fact, if we don't do something, by the end of this century, the climate will have risen by about 5 degrees centigrade. That's their projection from their models. They said if we don't do something, it keeps on warming, the ice cap, the Arctic and the Antarctic ice caps are going to disappear. It'll just be too warm. Polar bear population will decline because of no ice floats to get out on. That's not the environment they want. Sea level will rise by up to 88 centimeters by the end of this century. There'll be increased drought, extreme weather, more storms, more tornadoes, more hurricanes, more wildfires, etc. Everything will be worse. And towards the end of the talk, I'm going to show the reality of what we really are seeing. And this is the most significant threat to mankind. We must act now. If we don't do something, we're toast. So what is the reality? Here are some of the global warming projections. Now, there are many different governmental agencies which study this from a different perspective, and these are some of the ones I've looked at here. And you can see by the end of this century, they project anywhere from 2 to 5 degrees increase in temperature, average temperature of the world by the end of the century. The UN IPCC put out their first report in 1990, and they showed this, the temperature curve going back to the 1000 or before. Let's see if I can show that here. Well, it doesn't show very well. So anyway, you can see on the left-hand picture the medieval warm period. Remember when Greenland was green? And it was habitable. And then in the 1600s, we had a little ice age where everything froze. You know, the Thames River was frozen over in the wintertime. We don't see that now. And now, since then, we've come out of that. And yes, temperature is rising. We're coming away from a little ice age. So it's not unnatural. So that's what they put in the first report. In the second report, or the third, I think this is, 2001, here's the picture they put out. All those fuzzy lines, you know, there's a whole range of temperatures. But notice the medieval period seems to have been washed away, disappeared, or their picture. And you get this hockey stick curve at the end to say, yo, this is a real problem. If it's been flat all this time, and then going up by 0.5 degree centigrade, we got a problem. That's the message that they were giving. And that's, I'm sure you've heard of that phrase, the hockey stick. It looks like a hockey stick, you know, pretty well flat, and then all of a sudden a sharp curve up. Here's a comparison. You know, the original version promoted by the IPCC in the 20th century, you know, it showed this curve in red, okay? And it shows in 1950, we are warmer than it was back in the 1400s even. Is that real? The real curve, the correct curve, is the blue one. Remember the 1400 and before is that the medieval period, and really was warmer. And we are actually not at the temperature that it was back then. So again, the message is mixed there. Here's another one. It shows MIT researchers look at global warming data, and they showed the flawed data in red, and then the verified Met Office, the UK Met Office, showed it in blue, and you'll see that's lower. The real numbers are lower than they show in these NOAA. So again, the message is not being presented correctly. And here's another indication. The UK Met Climate Office put out this. This shows the fraud that's involved here. The red curve is the version published in 2015. And then notice that it stops there. That curve stops. And then they overlay it with this blue curve, which is the most recently published data. And you see that the blue is definitely, in 2015, it's above the red. So they left the red behind, said, no, we think it's going to be much higher than that. And here's one from NASA, which is really particular. As you'll see later in my presentation, 1930 was a hot period in the U.S. When you have droughts, real hot period. And then in the, you know, now they're saying, well, it's going to be hotter, but really the hottest period was in the 1930s. So here you see in 1999, you'll see it shows 1930s as very high. But by 2019, they've dropped that. So again, they're changing the data to match the message that they want to get out there. And in general, you know, we haven't gotten a whole lot warmer over the last 20, 30 years. Somewhat, but not a whole lot. And this is very pretty dramatic when you think of it. For those of you that lived in the 70s, we lived in Canada. We saw big snowbanks and all that. It's very cold. And now we don't see those snowbanks there the way we used to. So in 1973, 77, Time magazine say, hey, we're in trouble. We've got a big freeze coming up. If it gets any colder, we get real trouble. Who were the alarmists back then? Governor Jerry Brown in California. Dr. John Holdren happened to be Obama's science advisor. Dr. Paul Ehrlich. Okay, and then along comes the 2000, and now we've got global warming. You know, it's going to get so hot. We got to do something about this. Who's saying that? The same Jerry Brown, not his son. It's Brown Jr. He changed his mind after 30 years, as did John Holdren over those 30 years. He changed his mind, and of course, Al Gore, you know what he's saying? We're in deep trouble. We got to do something. So again, I've covered this pretty well here. The message had just changed from 1977 to 2014. Same people, different message. And you can say, well, hot, cold, what does it matter? No difference. And here's your favorite climate warming alarmist, Al Gore, 2008. He said the Arctic ice cap will disappear. Well, 2013, here's what it looks like. Lots of snow and ice. So that didn't happen. Just a little bit about what global warming, climate change is about, and some of the science behind it. We're not going to go very deep, but the point is that most of our energy, well, essentially all, comes from the sun. That's where the heat is. It comes from the sun, and scientists can measure the heat coming in, the incoming solar radiation in terms of watts per square meter. And they can measure, what's reflected off the clouds, reflected back to space, some reflected off the surface of the earth, and some absorbed by the surface. So these are the sorts of things that could be measured. So if things were stable, all these numbers would be the same. No, wouldn't change a whole lot. But there are changes, and I'll be getting into that. First of all, the word is that carbon dioxide is the problem. It's one of the greenhouse gases. And so, but if you include the water vapor, which actually is the largest one, but it doesn't make that much of a contribution, but it is the largest one. And then you also got methane and nitrous oxide and other miscellaneous gases. But what people are not told is that most of the warming is done by these gases, so-called, but who causes these gases? In the case of carbon dioxide, man increases, causes only 0.117 of all of the gases, 1%. So most of it, the 3.5 divided by 0.117, or 117 divided by 3.7, that's about 3% is caused by man. So if we stop doing everything, we don't get rid of the problem, if it's a problem. Here's another way to look at it. On the right there, the carbon dioxide, only 3% is man. Most of it is natural causes. And then if you compare it with water vapor, you'll see that carbon as a percentage is much smaller, but still it has an effect. So, and then if you look at the without water, which some of the models that the UN IPCC uses, they don't consider water vapor. They consider it a small determinant. But if you take water away, obviously carbon dioxide is the greatest determinant. But again, man causes only 0.3 or 3% of that. So that's a little bit of the background. And now I'm going to go through these 16 issues that I brought up. First of all, to state that climate is always changing. Here we've got our medieval warm period, again in the red, and you got the little ice age, the LIA. And that's the big picture. And the point is, it's always been changing. And you'll see the green is the number of parts per million of carbon dioxide in the atmosphere. Now it's over 400. This graph goes up to 400. But it is over 420 right now. And then they show this red part at the end of this curve, and that is supposedly causing that rise in the temperature there by the carbon dioxide. But is that true? Here's another picture, same kind of story. And then here it goes back 4,000 years, actually. And there's periods in history where we know it was warm, and other periods was much colder. And so in the Roman period, in the early centuries, after AD, there was a warm period, but not as warm as the medieval period. And then we got the little ice age, and then we're here at the end of that, and we're warming again. But notice it's not as warm as it was back in the medieval period. Okay, so the point is it goes up and down. We're going through cycles. It's not going any higher than the medieval period so far. The point is it's not something that we have to be overly concerned about. We need to watch it, but not overly concerned. The other thing that is confusing, you'll hear the politicians say sometimes, we got to stop producing all this carbon dioxide pollution. Well, carbon dioxide is not a pollutant. Plants need that. Plants use that. And in fact, the more carbon dioxide you have in the air, the faster and higher the plants will grow. And so you can talk about the positive effect having more carbon dioxide. Here's one picture showing the world grain production over the last 30 years or so. There's been a significant increase of the amount produced because it has been warming over those 30 years. And here's another pretty sharp curve. These colored points are the carbon dioxide emissions that are produced by different countries. Okay, you'll see that the U.S. is, of course, one of the largest, but China also halfway, three-quarters way up the curve there, is also a large producer. So, but the point is, in this black curve shows the corn yields have been increasing dramatically from the 1900s up to today's date. And part of that is due to the carbon dioxide in the air, the warmer weather. Issue number 3, you might ask, is the science not settled? You ask Al Gore, he will say it is. We shouldn't be asked these questions. Science is settled, so don't even bother. Well, look at the predictions they made. Here are some examples of predictions by this, again, same people, Paul Ehrlich, John Holdren, and the UN people. These predictions were made in the 70s and 80s, right, at the end of the 70s, about global cooling, but now we have global warming. So all the predictions have come to naught, as we'll further see. The UN overestimated global warming by 2015. All rainforest species will be extinct. That's one of the causes of global warming. Oil will run out by 2015. Well, obviously we're not running out of oil. Arctic sea ice will disappear by 2015. Well, I showed you one picture already. It's not disappearing. And a more extreme one, well, if we don't do something, many people would die. And here's another, and I know you can't read all of that from there, but going back to the 1970s, remember, we'll be in an ice age by 2000. 1976, global cooling will cause a world war by 2000. 89, global warming and rising sea levels will wipe entire nations off the map. You know, these low-lying islands in the Pacific will just wipe them out. And we have 5 to 10 years to save the rainforest. The Himalayan glaciers will be gone in 10 years. Snow will soon be a thing of the past. Our children, your grandchildren won't be able to enjoy snow anymore. Global warming will cause fewer hurricanes, but then 2012, they say global warming will cause more hurricanes. Conflicting predictions. And in 2014, well, the science is settled. Don't question what we're saying, it's settled. So again, I've just shown this curve in a different way, but the thing to remember is we had a warm period in the 1000 AD or so, and then we had a little ice age around 1600, and now we're coming out of the ice age. So that's the big picture that we're going through here. We had a period of cooling, 30 years in the mid-century, and that would be from roughly from 45 to 75 or 80. And what this shows is that the temperature, that's shown on the left here, correlates better with the sun rather than carbon dioxide use. And I'll show that more dramatically later on, and we'll come back to this. Here's another way of looking at it. You'll see the curve here, the dotted curve going through the middle of this. That is the amount of carbon dioxide parts per million, and it's 395 at the top there in roughly 2010, 2015. So that's a curve going up. But then the actual temperature, blue, is going up and then down. Well, the carbon is going up. So that doesn't match their story. Here's another way of looking at that whole period from over the last 2,000 years. The Roman warm period, medieval warm period, and the modern warm period. And here's the battle that's been going on. The person that came up with this idea of a hockey stick, which you see in the top curve on the right, is Michael Mann. He's a government worker, and he claimed that the temperature going up is going to get real serious. It's going to just keep on going up. He made a big deal about that, and he's the one that really triggered this whole global warming scare. There's a climate scientist in Tim Ball. He's been studying this for 50 years, and here's his version of it. Notice that Mann's version just shows pretty well flat from 1,000 to 1,600, and then slightly going up. Ball recognized the medieval period, hot, and then the little ice age in the 1,600, 1,700. And then at the 2000, we have warm periods again. So we go through cycles. And the point is this warm period is not as hot as it was back in medieval. And I say hot, but it's not really uncomfortable, just a few degrees. So there was a lawsuit by Tim Ball against Michael Mann. Said, give me the evidence for your hockey stick. Give me the data that you used to come up with that. They said, no, that's confidential. I can't show you that. Well, if you're in science, you have to share your data. You have to be able to run the same experiment. He would not show it. And so Tim Ball sued him, and it came out that Tim Ball won the case, and Michael Mann had to reimburse him for Tim Ball's expenses. Because note, he did not produce his data, because if he did, it would show that it didn't support the hockey stick, and then it would be a different charge against him. A few words about the NIPCC. see, this is the Non-Governmental International Panel on Climate Change. And they have a conference of hundreds of scientists once a year. And a lot of papers published, a lot of good quality papers. They're peer-reviewed, and they're published. They publish these 4 things I show at the bottom. One report concluded, nature, not human activity, rules the climate. And then climate change reconsidered 1 and 2. If you really look at it, climate change is not a problem, is what they're saying. And they give scientific critiques of the IPCC's models. And then a 4th book they produce is Why Scientists Disagree About Global Warming. And that's this book here. So some of their findings of the NIPCC, the IPCC would say there's a consensus of scientists who agree that global warming is a problem, and that most scientists agree on that. Well, they conclude there is no consensus among the scientists. And then they also explain why scientists happen to disagree, because they have different assumptions, and therefore they come up with different conclusions. And there's a certain amount of political science involved in the IPCC, as we'll see a bit later as well. They have flawed projects. They're not properly reviewed. They have false postulates, like false assumptions. They come up with the wrong conclusions. And they use unreliable circumstantial evidence to come to their conclusions. The problem is their false conclusions have policy implications. And that's what the whole climate change agreement was all about. Okay, so issue number 4, as you'll see, there are 4 possible causes of global warming. And I conclude, and many scientists conclude, that carbon dioxide cannot drive global warming. Okay, and here's why. This is a study, well, first of all, let me give a summary. There are 4 possible causes of global warming. One is, well, if there's more carbon dioxide in the atmosphere, it's going to get warmer. So we got to reduce the carbon dioxide. Global warming could be caused by sunspots. Sunspots can be very strong and very weak, and so why aren't the sunspots the cause of global warming? Well, it turns out their influence is too small to cause them by themselves, as we'll see. But there is a reaction that happens with the sun. It's called solar irradiance, which increases and decreases the cloud cover. And I'll get to that in a bit. And then the 4th one is a Pacific decadal oscillation, and that is the changes in the large oceans, the Atlantic and the Pacific, that occur every so many years, and that causes changes in the temperature as well. So first of all, is there any evidence for global warming by carbon dioxide? Scientists came up with these 4 telltale signs. If carbon dioxide was causing most of global warming, there should be a telltale hotspot warming pattern in what they examine in the atmosphere, and that doesn't appear. The ice cores, these are a certain number of ice cores, do not show carbon dioxide pushing up temperatures. And temperatures have not been rising for the last 20 or so years. You can see in that graph, yes, it's up and down, but there's no long slope up. And carbon dioxide already is doing almost the warming that it can. In other words, if you add twice as much carbon dioxide in the atmosphere, it's not going to have as much impact as the first half of that. And I'll show you a curve of that. Here's one of the measurements that scientists use. This red curve, this quickly red curve, is an indication of the number of parts per million of carbon dioxide in the atmosphere. And that's measured in Mauna Loa in Hawaii, and where there isn't much people living. It's a very quiet area. There's no cars running up those mountains and all that. So it's pretty accurate. And yes, indeed, it has been rising from about 320 up to 410 here. And then in the blue is the global temperature anomaly. Now, there definitely is it's going up, gradually. But you notice in the first part, the negative green part there, the carbon dioxide is going up, but the temperature going down. So it doesn't follow. And then we got a positive one, the pink one here, where the temperature seems to match the increase in the carbon dioxide. And then the last one, it's leveled off while the carbon dioxide keeps on increasing. So there's no 100% correlation between carbon dioxide in the atmosphere and the temperature. Here's what I was saying about the carbon dioxide in the atmosphere. At the bottom, you see the atmospheric concentration carbon dioxide in parts per million going from 20 to 540. Now remember, we're about 420 now, but we started out at about 300 or 280 100 years ago or so. And so, but the point is, the first amount of carbon dioxide in the atmosphere has the greatest impact. If there were nothing in the atmosphere, it would have a great impact. Plant growth needs up to more than 140 parts per million to be effective. And the more carbon dioxide you have, the better plant growth you have. But the other point is that every 20 parts per million increment of carbon dioxide in the atmosphere has less and less effect. So you can double the amount of carbon dioxide in the atmosphere and it would not have much impact on the temperature. That's been measured. Okay, number 5, this is the second possible cause of global warming, total solar radiation, TSI for short. It can cause significant fluctuations in the climate. And we see that here. You see the temperature in the red, and you see the carbon dioxide. Yep, they're both going to the right, up to the right. But then the other impact is the sunspots at the bottom here. The sunspots, the size of the sunspots, the strength of the sunspot is changing over time. And that causes the red line to go down sometimes and sometimes up. It doesn't follow the carbon dioxide, one for one. Here's coming back to that chart I showed before. The solar activity in the red here, or the blue, matches. You can see it goes up, the solar activity, and the Arctic temperature tracks that pretty well. And you don't see that for carbon dioxide. So there are indications that the temperature is correlated with the sun, not hydrocarbon. Now we come to our third cause, and that's this total solar irradiance. And I'll explain a little bit of the science in a bit here. But you can see from 1880 to 2000, you'll see the temperature in the black. It's going up and down. It's going up for a while, and then in 1945, you'll see to 1980, it goes down. That's that so-called global cooling that the Brown was warning about. And now we're definitely in a global warming period. But the amount there is not very significant. But the point is that the temperature matches the solar irradiance very well. But if you look at the second graph, you'll see that the temperature, same temperature graph, and the red line is the carbon growth. And you see that doesn't track the carbon dioxide growth. It's more in sync with the solar irradiance. And what is that solar irradiance? First of all, let's look at the sunspots for the last 400 years and where we are today. Remember we had the little ice age back in the 1600s? What was happening in the sun? very little activity, almost no sunspots, very low activity. And then we had a cold period. And then we have a warming, over these years here. And there was a dip here in 1900. But then you'll notice that in 80 or so, that's, pretty warm. But now we're at 2020, and you'll see that the sunspots have been decreasing gradually. And the projection of the scientists actually is that they will keep decreasing. And that you see that red. These are projections, of course, but that's the modern minimum is very similar to the Maunder minimum. So after 2050 or so, we could be in a real global cooling period. But these are the best projections of the scientists at this time. So what is this solar irradiance all about? Well, what happens when the sun, there are cosmic rays in the atmosphere throughout space, and magnetic fields can play with the number of cosmic rays in the atmosphere. And so if there are a lot of cosmic rays coming down to the Earth, you get more clouds. And the more clouds you have, the cooler it's going to be. Because it stops, the clouds have stopped the release of the heat somewhat. If there are low cosmic rays, that means that the sun is very hot, a very strong magnetic field coming from the sun. They stop the cosmic rays, and therefore there aren't as many clouds. And therefore you have a hotter Earth. So there's a link there, and that link is greater than the link of the carbon dioxide in the atmosphere. And this shows the red is the cosmic ray count. You'll see when the cosmic ray count is high, the sunspots are low. When the sunspots are higher, the cosmic rays are lower. So there's a real reverse correspondence there. Okay, this is just a few more words about that. So looking at these sunspots again, the NASA prediction is solar cycle number 25, which we're approaching, is going to be very weak. And therefore, we're going to enter a cooling period, just like back in the Maunder minimum. Okay, 6. The fourth possible cause of global warming is the activity in the ocean, Pacific decadal oscillations, and that can cause some significant fluctuations in the climate. And this shows here, where the Dr. Roy Spencer is a climate scientist working for the University of Alabama. And he's a climate scientist, and he writes quite a bit about that. He's a believer, and he doesn't believe that the threat of global warming is real, not like the UN IPCC is predicting. So we have El Nino and La Nina operations in the ocean, and we have volcanoes as well, and they impact the average temperature, the average surface temperature. They can impact as well as the solar irradiance. And there's a lot of, this is very complex science. So there's a lot of discussion about which is really causing the most. But these two are the biggest ones, solar irradiance and activity in the oceans. Carbon dioxide is a minor. It is impacting the average global temperature because it does hold in the gases. The ocean, these are measurements. The ocean is barely warming from 2005 to 2014. You can see they project very small. You can see on the right is the scale from 642 degrees centigrade to 645, very, very small. So just by this here, the ocean warming would only cause 0.23 degrees centigrade in 100 years. Okay, issue number 7. I'm sure you've all heard the Paris Climate Agreement. This is where the nation got together in Paris and said, yeah, we're going to do something about the global warming. We've got to stop this. And many nations agreed to that, and the U.S. was one of those. And as you know, when Trump got in office, he nixed that, and there were very good reasons for doing that, because this came about through the work, the UN Framework Convention. It deals with greenhouse gas emissions, how to mitigate it, how to adapt to it, and how do you pay for this, if indeed it is such a significant thing. It was adopted by 144, well, signed by 195 nations, ratified by 144. Those are the ones that ratified said, yeah, we will do what we promised. But the point is, if they did all the things that the Paris Climate Agreement asked these countries to do, you could only prevent an increase of temperature of 0.3 degrees Fahrenheit caused by global warming by 2100, and it would cost anywhere from $65 to $132 trillion to control that. And as you know, government programs always cost more than they say they're going to cost. So a very, very significant cost at very, very little gain. Great gain for, or little gain for great pain. And this, I'm not going to read all this to you. This is the 6 key points that the agreement came up with. Keeping the temperature increase less than 2 degrees centigrade was one of them. All countries would submit that they would reduce greenhouse gas pollution. And the developing countries, like the Western countries, would have to contribute something like $100 billion a year in finance. And that would mostly go to the developing countries. And here's an interesting part of that. The Obama administration at the time agreed to an economy-wide target of reducing greenhouse gases by 26 to 28%. And a lot of that would be carbon dioxide below its 2005 level. And 20 years from then. That is, they have to reduce the 400 parts per million of carbon dioxide by 26 to 28% to meet that agreement. That's very difficult to do. So the U.S. is obviously a developed country. China, however, is a developing country, so they don't have those restrictions. But they agreed to achieve the peaking of carbon dioxide emissions around 2030. In other words, they're going to keep on building coal plants and until 2030 as much as they can, and then maybe we'll think about reducing it. So guess who's paying the bill for that? Number 8, and this is a biggie. The climate models are not realistic. The models that they came up with, the IPCC back in 2007, and they said they had 90% confidence that this would happen for these models. And they're showing, that 5 to 6 degrees centigrade by 2100. And there's a whole bunch of different people which put in different estimates. And here's a refined look at these estimates by 2050. So there are different drafts over the last 10 years or so. And the models and the projection keep on changing as they come up with new models. But the result of all that, they've come up with a whole bunch of different models, and those curves, there's 120 curves, or 102 different curves shown here. And that red line, the dark red line through the middle, is sort of the average of all their models. So this is what they projected to happen, and it goes out to 2025, and of course now we're at 2021. So here's their projections, but then what they measured was these blue dots around here. So they're nowhere near the projections that the UN IPCC is making. It's not as bad as they say it's going to be. And okay, number 9. Surface weather stations give less accurate and higher average temperatures than satellite measurements. It used to be before 1979, all temperature measurements were done by weather stations on the ground or in ships or what have you, all across the world. But then in 1979, they introduced satellite measurements. So what's the problem with these temperature measurement weather stations? Well, looking back at 1950, you'd have weather stations, some in rural areas and some in urban areas. And guess what? The ones in urban areas are going to produce higher temperature because of the more asphalt and buildings, and that's just going to be hotter. They're going to measure hotter temperatures than out in the country. So over time, the urban area runs into the rural area, and so if they keep on using that weather station there, it will show hotter temperatures over time. And so that's not a good way to measure it. And so you have what they call the urban heat island impact. So like here, why is it warmer in the city? Here, city 92% Fahrenheit, 82 in the suburb, or 88, and then 85 in the rural areas. Quite a big difference. So it depends which weather stations you use to measure average temperature, is what the average temperature comes up to be. And here's just some examples of that. For example, in the where the Dulles Airport, the Reagan National airports are, they're in populated areas. Over time, from 2000 to 2014, the temperature increased significantly. Because before this was rural areas, and that temperature would increase by 14 degrees per century is what they projected. That's the model they used. But in the rural areas, they show it actually decreasing. So it depends on which weather stations you use. Here's an example of a possible result of that. The correlation of average temperature and the number of surface stations. Going from 1950 to 2000, the number of stations, is the number of stations, the dotted line, decreased over time. There's fewer and fewer stations being used, and the average temperature went up significantly. There's a correlation between that. The fewer stations you use, and particularly if you use fewer stations in their rural areas, you're going to get hotter measurements because you're using all the urban temperature measurements. So it's not a real average temperature measurement. So now they're starting to use satellite-based temperature measurements, and this work is supported by the UAH, that's the University of Alabama, and that they have tracked this from 1979 to 2021 so far, and notice that the range is about 0.6 in 1998, and it's as low as minus 0.6 in 1984. Very significant range. But if you draw a line through it, the red line, it's not moving very far. In fact, the latest data point in March 2021 is below average. So we're already coming down in average temperature over the last few years here. And of course, it fluctuates even month by month, but it's definitely going down. Another projection was that the number of polar bears would even become extinct because there's no snow for them to, or ice floes to be out on. Well, in 1960, there were 5,000 polar bears now in the northern country, Canada in particular, and there's 25,000 or more polar bears. So they didn't go down. That's not a problem. An inconvenient fact. Number 11, sea levels are not rising as fast as predicted. Over the last century, from 1880 to 1980, it went from -4, the average, to +4 centimeters. 8 centimeters total change. Not a big change. But the sea level rise projected up to, for 2100, are as much as 120 centimeters. So the projections are way up there. But there's no, we can't see getting there. And here's a more accurate measurement, looking at sea level. It turns out it really is unaffected by carbon dioxide. You'll see it goes from 6.90 meters to about 7.05 meters from 1840 to 2020. And the green line going through there, that's the increase in carbon dioxide in the atmosphere. So there's no real strong correlation there. This, I'm not going to read it all, but essentially what it says is that some changes in measurements are due to land actually sinking and other lands actually rising. Like in the Netherlands, land is sinking. And so it looks like the ocean is rising on them, but it's not. The land is sinking. And in Norway, Sweden, the land is actually rising. So the temperature, the ocean level that you're measuring, is not correct. So it's not as big a problem as they projected. Okay, number 12, Arctic sea ice is not disappearing. Remember, it was projected to disappear. On the right, you see in 2012, the size of the Arctic ice cap. On the left, 1 year later, same month, it's much greater. So it's not disappearing by any means. And this is another way to look at it here, sea ice thickness. And they can measure that sea ice volume in that curve on the top right there. And the different color lines are different years that they measured it from January to January. And of course, in the summer months, it's the least thick. But you notice the average doesn't change a whole lot. There's no migration to losing ice there. And this shows another one here, where this central line is the average. But you'll notice here in the winter temperature polls in 2016 were higher. In 2019, the average is lower in that purple score. So there's no large trend there. Okay, now we come to a big one, and that is, you often hear it said, well, we're having more hurricanes, more tornadoes, more storms, more forest fires, all these things. Well, what's happening? First of all, drought. Said we're having more and more drought. I mean, that was a problem in California. They said we're going to get more drought if it gets drier and drier. Well, if you look at the drought historically, you'll see the red is where it is drier, and so in all the way back to 800, goes to 2000 here. You'll see as we approach 2000, the blue means it's actually wetter. It's wetter now than it was back in the 1,000 years ago. And if you look from 1900 to 2000, change in drought percentage, not much difference, 65 to 67. As the average line is pretty flat. Intense hurricanes. These are the number of Cat 3, 4, and 5 hurricanes occurring. And you'll see every, in a certain decade, there's a different number, but it goes up and down, up and down. And we got a 2009, yep, it's more, but the average through all that is still downtrend. And the deadliest U.S. states hurricanes when they occur. Well, if you look at these numbers, 1900 was the largest fatality in Galveston. And 2005, Katrina, that was a pretty bad storm, but it's only 1,200 compared to 12,000. And 2017 is the other one, 2,900, but there's others, much higher than that. There's no trend in that, is the point. U.S. tornadoes, again, you can measure the ones that are stronger than 3, and you'll see the count from 1970 to 2015. There's definitely a line going down. Strong tornadoes is another curve also going down. Extreme weather, tropical storms on the top, and the number of hurricanes on the bottom there, the dotted line. You'll see again from 1970 to 2010, it's, there's no measurable trend, down if anything, but nothing big. Okay, then it comes to, people say it's gotten a lot hotter these days. Well, if I know we weren't living down then, most of us weren't living in the 1930s, but that was a real hot period, one of the hottest we've had in the U.S. for a long time, and there are definitely peaks there. Another way to show it, the average maximum temperature from the year 1900 to 2020. You'll see the number of days with maximum temperature actually was the strongest in the 1930s again. And here, we get some real high points, but real low points as well. But the curve is still down. It's not a dramatic curve up. And U.S. temperature, again, we really haven't warmed all that much from 1880 to 2000, especially when you consider the 1930 peak there. The temperature now is lower than the peak in 1930. The average number of days over 95 degrees from 1900 to 20, again, that curve we have experiencing less and less. And again, the peak was in the 1930s. So we are cooler than then. Okay, here's another example of how the scientists can manipulate the data and make it appear to match their agenda, I'll say. So here you've got let's see. The average here in the 5-year mean, the 5-year mean is the red, and the average mean is the line going here. And you'll see here that the temperature in 1930 was higher than it is today. And this was, I guess, let's see, yeah. And then later on, from 1951 to 80, you'll see that, these temperatures now are right on par with, or even higher than 1930. But they've adjusted the data to show that, to make it seem that way. The frequency of wildfires, again, it's been said, well, we'll get more wildfires than we ever had. Well, from 1985 to 2013, there's no big deviation from what is, there's no curve going up. It's pretty up and down. And here's one that really, the U.S. forest fire burn acres, in other words, how many acres were burned. Well, when you look in the stories in the papers, you'll see them show the date from 1960 to 2018. And in the middle of the graph, you'll see it, well, that definitely is lower than we have today. Look at today, it's way up there. It's almost twice as much as it was in 1970. So the curves definitely go up. But they don't show you the rest of the curve. Going back to the 1900s, the early 1900s, you have much more acres burned than we do today. So it's called cherry picking the data to make your point. And this is another one here, annual and 5-year acreage burned. And you'll see again, from 64 to 2006, there seems to be a slight grade up. But if you just show that and neglect showing back to 1928, when there are a lot more acreage burned than there are today. Okay, then snow. Some people projected, well, we're going to see less snow. But they have measured the snow extent from 1967 to 2019, and you'll see there's some large points up here, millions of square kilometer of snow, and there's low ones here in 1991 and high ones here. But on the average, the curve is going up. We're getting more snow on average than we used to. And here's another one here. This is the snow mass for northern hemisphere, excluding the mountains. And the blue area is sort of the average range of the snow mass. But here, for 2019 to 20, what we're seeing is this red dotted line. So it's higher than the average has been for the last 20 years or so. So we're getting more snow, and I know back east in Europe, they have had huge snowstorms this year. Number 14, the UN IPCC Charter limits itself to identifying only human causes of global warming. There are natural causes, but the UN IPCC only looks at human causes. Here's their charter. The charter from the outset said to assess on a comprehensive, objective, open, transparent basis the scientific, technical, socioeconomic information relevant to understanding the scientific basis of risk of human-induced climate change. Okay, so they don't look at the natural causes because we can't control that anyway, but they're looking at human-induced, and that's why there's so much emphasis on carbon dioxide. Here's just the reports they do every 5 years or so. The first one, they ignored the satellite data, which showed average temperatures were lower than the surface weather stations. Report 2, significant alterations after approval by scientists. A scientist would approve it, but the final reports are written by the bureaucrats, not by the scientists. Report number 3, the claim 20th century showed unusual warming. Number 4, completely devaluated climate changes in solar activity. In other words, they ignore the warming caused by solar activity. Report number 5, confidence of their projections increased to 90 to 95% despite no global warming for 15 years at a time. So in other words, there's an agenda behind this. Issue number 15, and here's part of that agenda. UN officials admit that its real agenda is to redistribute wealth. And here's one UN IPCC officer saying this: we redistribute de facto the world's wealth by climate policy. One has to free oneself from the illusion that international climate policy is environmental policy. This has almost nothing to do with environmental policy anymore. So again, their agenda is not how can they limit the climate changes or anything, but it's to redistribute the wealth. You notice from the Paris Agreement, where was the money coming from? From the rich developed countries. Where is it going to? The developing countries or the poorer countries. And here, the final one, issue number 16. I'm sure you've heard Obama and John Kerry and other officials say 97% of climate scientists say that we have a real global warming problem that we need to mitigate. Where do they get that from? This is said to be the most widely repeated claim in the debate over global warming. 97% of scientists agree. That sounds like a pretty strong statement, but it's not true. In May 2014, Secretary of State John Kerry warned graduating students at Boston College of the crippling consequences of climate change. 97% of the world's scientists tell us this is urgent. 97%. They didn't ask me. 3 days later, or earlier, President Obama tweeted that 97% of scientists agree climate change is real, man-made, and dangerous. Those are the words they use. And as you can see by what you've seen, the words don't match what's really happening out there. There were actually 7 studies done by different people and asking questions. And all of them came out with a range of so-called scientists agree of anywhere from 90 to 100%. Very, very large numbers. And this, just one of those surveys was like this. The Doran survey, 2 questions. When compared with the pre-1800 levels, do you think that mean global temperatures have generally risen, fallen, or remained relatively constant? Well, anybody that's followed what's going on, it would say yes. I'll say yes, definitely, it's been going. But that's not the question has been rising to cause a crisis. That's what the question you need to ask. And then question number 2, do you think human activity is a significant contributing factor in changing mean global temperatures? Well, what do you mean by significant? And how do you measure that? I mean, it's very, very strange. So, but notice that who the survey went out to, it was limited to academic and government workers who get the government money for the grants to do the studies. Solar scientists and meteorologists were excluded from the survey. So they got responses from 3,000 people. And let's see if I can show it here. Yeah. They sent it out to 10,000. They got a survey back from 3146. And then they looked at only the climate scientists, what they had to say. There are 77 climate scientists who responded. 75 of them answered yes to question number 2. So 75 over 77, 97%. You start with 10,000, you're just looking at these 77 people. So they're bogus surveys. So in conclusion then, here are some reasons the secular scientists think that the Earth's climate is unstable. First of all, the climate models that they use are totally inaccurate, totally useless. The question is there a feedback system in the atmosphere? Or is there a runaway positive feedback, as some of these climate models will indicate? But in reality, there is a negative feedback in the atmosphere, and there is controls. Fraudulent, politicized research. You'll see using more surface weather stations and satellite temperatures can have a great difference in what average temperature you come up with. The data is cherry-picked in some cases it's even manipulated to support their agenda. Those are the major reasons why the secular scientists come up with that story. What the news media isn't telling you, where have you seen in CNN or some of the mass media, there has been no global warming for 19 years. Global warming from 78 to 1998 has been now replaced by global cooling. The Antarctic ice sheet is growing. It's not melting like they're telling you. Sea level is rising maybe by 7 inches per century, not by 20 feet per century. 4 of the past 5 years have set snowfall records. CO2 is so small of a fraction of the atmosphere. Of all the atmospheric gases, the greenhouse gases, CO2 is only 0.04% of all the greenhouse gases. And yet they're saying that's the one that we have to worry about. Severe storms are not more frequent than normal, and oceans are not acidic. So what should we do as the church? Well, we need to commit to viewing the world from God's perspective, understand and rely on Scripture as a foundation for life. Going back to this promise that God made in Genesis 8:22, while the earth remains seedtime and harvest, cold and heat, summer and winter, day and night shall not cease. So there will always be seasons. We're promised that. We should use the Bible to understand the world and evaluate problems. We should help inform other believers, and again, need to promote the truth and oppose the false beliefs with gentleness and respect. So in conclusion then, the UN IPCC climate change models have failed miserably. They're not telling the true story. There has been no significant global warming for the last 19 years or so. Sea levels only increased by about 1.5 millimeter per decade, and man-made causes are insufficient. Carbon dioxide, as I said, is too small of a component of the atmosphere to control our environment. Natural causes of climate change are more credible. You know, all of our energy comes from the sun, after all. But the energy in itself is insufficient, but the interaction between the sunspots and the magnetic storms, the waves induced by the sun and the sunspots, they can explain a lot of the temperature measurements or the temperature changes that we have seen. And the movements of the large oceans can also explain some of the climate change we've seen. And the Paris Climate Agreement that they came up with in 2015 is not a solution for a non-existent problem, but is a very expensive solution. So climate change is not a crisis. Let's not panic. We have to keep ourselves, we have to be informed and deal with those issues, but we shouldn't panic about that. Father, we come to you this evening just to thank you that you have given us information, and we can trust your word, Lord, as we saw at the beginning of this talk, that you have given us promises, and we see those being fulfilled, and you have given us instructions to take care of the environment that you have produced for us to live in. And Lord, we just thank you for that, and we thank you for the information that you have made available to us that we can understand. And you tell us to always test everything that we're being told, Lord, and see if it's true or not, and to make our decisions based on whether we see your truth in that or not. And we just thank you for the scientists who are working to help us to understand your earth and the environment around it and what we should do to protect it, Lord. And we just ask that the word would go out and inform people. In Jesus' name we pray. Amen.
Amen.